Building information modeling is a process involving the generation and management of digital representations of physical and functional characteristics of places. Building information models are files which can be exchanged or networked to support decision-making about a place. Current BIM software is used by individuals, businesses and government agencies who plan, design, construct, operate and maintain diverse physical infrastructures, from water, wastewater, electricity, gas, refuse and communication utilities to roads, bridges and ports, from houses, apartments, schools and shops to offices, factories, warehouses and prisons, etc. Origins of BIM. The concept of BIM has existed since the 1970s. The term Building Information Model first appeared in a 1992 paper by G. A. van Niederveen and F. P. Tolman. However, the terms Building Information Model and Building Information Modeling had not been popularly used until 10 years later when Autodesk released the white paper entitled Building Information Modeling. Jerry Lycerin helped popularize and standardize the term as a common name for the digital representation of the building process as then offered under differing terminology by Graphisoft as virtual building, Bentley Systems as integrated project models, and by Autodesk or Vectorworks as building information modeling to facilitate exchange and interoperability of information in digital format. According to Lycerin and others, the first implementation of BIM was under the virtual building concept by Graphisoft's ArchiCAD, in its debut in 1987. Definition: the U.S. National Building Information Model Standard Project Committee has the following definition: Building information modeling is a digital representation of physical and functional characteristics of a facility. A BIM is a shared knowledge resource for information about a facility forming a reliable basis for decisions during its life cycle. Defined as existing from earliest conception to demolition. Traditional building design was largely reliant upon two-dimensional drawings. Building information modeling extends this beyond 3D, augmenting the three primary spatial dimensions with time as the fourth dimension and cost as the fifth, etc. BIM therefore covers more than just geometry. It also covers spatial relationships, light analysis, geographic information, and quantities and properties of building components. BIM involves representing a design as combinations of objects vague and undefined, generic or product-specific, solid shapes or void space-oriented, that carry their geometry, relations and attributes. BIM design tools allow extraction of different views from a building model for drawing production and other uses. These different views are automatically consistent, being based on a single definition of each object instance. BIM software also defines objects parametrically. That is, the objects are defined as parameters and relations to other objects, so that if a related object is amended, dependent ones will automatically also change. Each model element can carry attributes for selecting and ordering them automatically, providing cost estimates as well as material tracking and ordering. For the professionals involved in a project, BIM enables a virtual information model to be handed from the design team to the main contractor and subcontractors and then on to the owner-operator. Each professional adds discipline-specific data to the single shared model. This reduces information losses that traditionally occurred when a new team takes ownership of the project, and provides more extensive information to owners of complex structures. BIM throughout the project life cycle. Use of BIM goes beyond the planning and design phase of the project, extending throughout the building life cycle, supporting processes including cost management, construction management, project management and facility operation. Management of building information models. Building information models span the whole concept to occupation time span. To ensure efficient management of information processes throughout this span, a BIM manager might be appointed. The BIM manager is retained by a design-build team on the client's behalf from the pre-design phase onwards to develop and to track the object-oriented BIM against predicted and measured performance objectives, supporting multidisciplinary building information models that drive analysis, schedules, takeoff and logistics. Companies are also now considering developing BIMs in various levels of detail, since depending on the application of BIM, more or less detail is needed. and there is varying modeling effort associated with generating building information models at different levels of detail. BIM in construction management. Participants in the building process are constantly challenged to deliver successful projects despite tight budgets, limited manpower, accelerated schedules, and limited or conflicting information. The significant disciplines such as architectural, structural and MEP designs should be well coordinated, as two things can't unregistered trademark take place at the same place and time. Building information modeling aids in collision detection at the initial stage, identifying the exact location of discrepancies. The BIM concept envisages virtual construction of a facility prior to its actual physical construction, in order to reduce uncertainty, improve safety, work out problems, and simulate and analyze potential impacts. Subcontractors from every trade can input critical information into the model before beginning construction, with opportunities to prefabricate or preassemble some systems off-site. Waste can be minimized on-site and products delivered on a just-in-time basis rather than being stockpiled on-site. Quantities and shared properties of materials can be extracted easily. Scopes of work can be isolated and defined. Systems, assemblies and sequences can be shown in a relative scale with the entire facility or group of facilities. BIM also prevents errors by enabling conflict or clash detection whereby the computer model visually highlights to the team where parts of the building may wrongly intersect. BIM in facility operation. BIM can bridge the information loss associated with handing a project from design team, to construction team and to building owner-operator, by allowing each group to add to and reference back to all information they acquire during their period of contribution to the BIM model. This can yield benefits to the facility owner or operator. For example, a building owner may find evidence of a leak in his building. Rather than exploring the physical building, he may turn to the model and see that a water valve is located in the suspect location. He could also have in the model the specific valve size, manufacturer, part number, and any other information ever researched in the past, pending adequate computing power. Such problems were initially addressed by Light and Archinchi when developing a vulnerability representation of facility contents and threats for supporting the identification of vulnerabilities in building emergencies. Dynamic information about the building, such as sensor measurements and control signals from the building systems, can also be incorporated within BIM to support analysis of building operation and maintenance. BIM software. Due to the complexity of gathering all the relevant information when working with BIM on a building project, some companies have developed software designed specifically to work in a BIM framework. These packages differ from architectural drafting tools such as AutoCAD and Vectorworks by allowing the addition of further information to the building model. Non-proprietary or open BIM standards. BIM is often associated with industry foundation classes and Building Xml Euro data structures for representing information. IFCs have been developed by Building Smart, as a neutral, non-proprietary or open standard for sharing BIM data among different software applications. Poor software interoperability has long been regarded as an obstacle to industry efficiency in general and to BIM adoption in particular. In August 2004, the U.S. National Institute of Standards and Technology issued a report which conservatively estimated that $15.8 billion was lost annually by the U.S. capital facilities industry due to inadequate interoperability arising from the highly fragmented nature of the industry, the industry unregistered trademark's continued purpose business practices, a lack of standardization, and inconsistent technology adoption among stakeholders. An early example of a nationally approved BIM standard is the AISC-approved CIS/2 standard, a non-proprietary standard with its roots in the UK. There have been attempts at creating a BIM for older, pre-existing facilities. They generally reference key metrics such as the Facility Condition Index. The validity of these models will need to be monitored over time, because trying to model a building constructed in, say 1927, requires numerous assumptions about design standards, building codes, construction methods, materials, etc., and therefore is far more complex than building a BIM at time of initial design. International BIM Developments, Asia, Hong Kong. The Hong Kong Institute of Building Information Modeling was established in 2009. The Hong Kong Housing Authority set a target of full BIM implementation in 2014/2015. Building Smart Hong Kong was inaugurated in Hong Kong SAR in late April 2013. India. In India, BIM is also known as VDC, Virtual Design and Construction. India is an emerging market with an expanding construction market and huge potential for large-scale residential and commercial development. It has many qualified, trained and experienced BIM professionals who are implementing this technology in Indian construction projects and also assisting teams in the USA, Australia, UK, Middle East, Singapore and North Africa to design and deliver construction projects using BIM. Iran. The Iran Building Information Modeling Association shares knowledge resources to support construction engineering management decision-making. It was founded in 2012 by professional engineers from 5 universities in Iran, including the Civil and Environmental Engineering Department at Ahmadiyya University of Technology. Singapore. The Building and Construction Authority has announced that BIM will be introduced for architectural submission, structural and M&E submissions and eventually for plan submissions of all projects with gross floor area of more than 5,000 square meters by 2015. South Korea. Small BIM-related seminars and independent BIM effort existed in South Korea even in the 1990s. However, it was not until the late 2000s that the Korean industry paid attention to BIM. The first industry-level BIM conference was held in April 2008, after which, BIM has been spread very rapidly. Since 2010, the Korean government has been gradually increasing the scope of BIM-mandated projects. McGraw-Hill published a detailed report in 2012 on the status of BIM adoption and implementation in South Korea. Europe. In a number of European countries, several bodies are pushing for a more integrated adoption of BIM standards, in order to improve software interoperability and cooperation among actors of the building industry. Hungary. Hungarian BIM Council, France. In France, examples include the FFB, and the French arm of Building Smart. Lithuania. Lithuania is moving towards adoption of BIM infrastructure by founding a public body Skaitmena, Statyba, which is managed by 13 associations. The initiative intends Lithuania to adopt as standard, BIM, industry foundation classes, national construction classification, an annual international conference Skaitmena, Statyba Lita, which has been held since 2012. Norway. In Norway, BIM has been used increasingly since 2000. Several large public clients require use of BIM in open formats in most or all of their projects. The Government Building Authority bases its processes on BIM in open formats to increase process speed and quality, and all large and several small and medium-sized contractors use BIM. National BIM development is centered around the local organization, Building Smart Norway, which represents 25% of the Norwegian construction industry. Switzerland. In Switzerland, ETH Zurich University has taught CAD and digital architecture since 1992 through Professor Dr. Schmidt. During 2013, BIM awareness among a broader community of engineers and architects was raised due to the open competition for Basel's Felix Platter Hospital, where a BIM coordinator was sought. BIM has also been a subject of events by the Swiss Society for Engineers and Architects, SIA. The Netherlands. On November 1, 2011, the Rijksbouwdienst, the agency within the Dutch Ministry of Housing, Spatial Planning and the Environment that manages government buildings, introduced the RGD norm, which it updated on July 1, 2012. United Kingdom. In the UK, the Construction Project Information Committee, responsible for providing best practice guidance on construction production information and formed by representatives of major UK industry institutions, has produced a similar definition to that produced by the US National BIM Standard Project Committee. This was proposed to ensure an agreed starting point, as different interpretations of the term were hampering adoption. In May 2011, UK Government Chief Construction Advisor Paul Morrell called for BIM adoption on UK government construction projects of £5 million and over. Morrell also told construction professionals to adopt BIM or BB to maxed out. In June 2011, the UK government published its BIM strategy, announcing its intention to require collaborative 3D BIM on its projects by 2016. Initially, compliance will require building data to be delivered in a vendor-neutral COBie format, thus overcoming the limited interoperability of BIM software suites available on the market. The UK Government BIM Task Group website gives a clear message to the whole supply chain about the government's BIM programme and requirements. National Building Specification, owned by the Royal Institute of British Architects, publishes research into BIM adoption in the UK. There have now been 4 annual surveys. The April 2014 survey of 1,000 UK construction professionals revealed that BIM adoption had increased from 13% in 2011 to 54% in 2014. Several UK-based websites host BIM objects, including those of many construction product manufacturers. North America, Canada, founded in December 2008. The Canada BIM Council is a consensus and committee-driven organisation for BIM in Canada developed by business leaders to standardise the use of models in architecture, engineering and construction. United States of America, the Associated General Contractors of America and U.S. contracting firms have developed various working definitions of BIM that describe it generally as an object-oriented building development tool that utilizes 5D modeling concepts, information technology and software interoperability to design, construct and operate a building project, as well as communicate its details. Although the concept of BIM and relevant processes are being explored by contractors, architects and developers alike, the term itself has been questioned and debated with alternatives including virtual building environment and virtual design and construction also considered. BIM is seen to be closely related to integrated project delivery where the primary motive is to bring the teams together early on in the project. A full implementation of BIM also requires the project teams to collaborate from the inception stage and formulate model sharing and ownership contract documents. The American Institute of Architects has defined BIM as a model-based technology linked with a database of project information, and this reflects the general reliance on database technology as the foundation. In the future, structured text documents such as specifications may be able to be searched and linked to regional, national, and international standards. Anticipated future potential, BIM is a relatively new technology in an industry typically slow to adopt change. Yet many early adopters are confident that BIM will grow to play an even more crucial role in building documentation. Proponents claim that BIM offers improved visualization, improved productivity due to easy retrieval of information, increased coordination of construction documents, embedding and linking of vital information such as vendors for specific materials, location of details and quantities required for estimation and tendering, increased speed of delivery, reduced costs. BIM also contains most of the data needed for building energy performance analysis. The building properties in BIM can be used to automatically create the input file for building energy simulation and save a significant amount of time and effort. Moreover, automation of this process reduces errors and mismatches in the building energy simulation process. Green Building XML is an emerging schema, a subset of the building information modeling efforts, focused on green building design and operation. GBXML is used as input in several energy simulation engines. With the development of modern computer technology, a large number of building energy simulation tools are available. When choosing which simulation tool to use, the user must consider the tool's accuracy and reliability, considering the building information they have at hand, which will serve as input for the tool. Yezero, Dong and Light developed an artificial intelligence approach towards assessing building performance simulation results and found that more detailed simulation tools have the best simulation performance in terms of heating and cooling electricity consumption within 3% of mean absolute error. Explorations are underway to pair computer network users' personal, private and public authentication choices, geographic mapping systems and evolving cloud computing security architecture models, together, to offer customers of geospatial securitization services intuitive new ways to organize their personal, private and public applications and storage. For individuals, businesses and government authorities who generate and manage building information, new ways to discover, share and work on data, within the context of particular places on Earth, will be offered. David Plaga, AIA, conjectures that today's web will give way to tomorrow's geo-web where data will be structured first by place and then by space, private and public. See also, 3D modeling, 4D BIM, 5D BIM, 6D BIM, architectural engineering, architecture, BIM wash, construction management, design computing, integrated project delivery, virtual design and construction, whole building design guide, additional resources, Eastman, Chuck. Teicholz, Paul. Sachs, Raphael. Liston, Kathleen. BIM Handbook, a guide to building information modeling for owners, managers, designers. Wiley. ISBN A978-0-470-18528-5, Hardin, Brad. BIM and Construction Management, Proven Tools, Methods and Workflows. Sibes. ISBN A978-0-470-40235-1, Jernigan, Finnith. Big BIM Little BIM. Foresight Press. ISBN A978-0-9795699-0-6, Kaziltas, Semir. Light, Fernando. Arkinchi, Berku. Lipman, Robert R. Interoperable Methodologies and Techniques in CAD. Inkomi, Hussein A. Arkinchi, Berku. CAD and GIS Integration. CRC. PPA 73 €109. ISBN A978-1-4200, 6806-1, Kimmel, Willem. Building Information Modeling, Planning and Managing Construction Projects with 4D CAD and Simulations, McGraw-Hill Professional. ISBN 978-0-07-149453-3, Krigiel, Eddie and Nyes, Brad. Green BIM, Successful Sustainable Design with Building Information Modeling, Sibes. ISBN 978-0-470-23960-5, La Copyright v. Frenner Section WA. BIM and Small-Scale Sustainable Design, Wiley. ISBN 978-0470590898, Smith, Dana K. and Tardif, Michael. Building Information Modeling, A Strategic Implementation Guide for Architects, Engineers, Constructors, and Real Estate Asset Managers, Wiley. ISBN 978-0-470-25003-7, Underwood, Jason, and Isaac Dag, UMIT. Handbook of Research on Building Information Modeling and Construction Informatics, Concepts and Technologies, Information Science Publishing. ISBN 978-1-60566-928-1, Wiegand, Robert S. BIM Content Development, Standards, Strategies, and Best Practices, Wiley. ISBN 978-0-470-58357-9, References. External links, What is BIM? A Euro by Professor Charles M. Eastman, Director of AEC Integration Lab at Georgia Tech. GSA National BIM Program, a Euro National 3D/4D BIM Program by the US GSA. BIM articles, a Euro cross-industry expert articles on the subject of building information modeling. UK National BIM Report 2011, a Euro National Report into UK attitudes to BIM in 2011. UK National BIM Report 2012, a Euro National Report into UK attitudes to BIM in 2012. UK National BIM Report 2013, a National Report into UK attitudes to BIM in 2013, UK National BIM Report 2014, a National Report into UK attitudes to BIM in 2014, UK Government BIM Task Group website, the UK Government's BIM Programme and Requirements, IBIMA Iran Building Information Modelling Association, CAD Addict list of existing BIM standards. BIM as the future. BIM is a revolutionary movement of the management, design and construction,